Okay, good afternoon, everyone. This is Ben Clothier. And if you don't know me, I'm deaf if you didn't know. So you won't hear a man's voice, you'll hear an interpreter's voice. So if anyone has any questions, please go ahead and interrupt, or if you're following along with the book, you can. It's effective SQL. And I think what we're going to do tonight is we're going to cover 4 different topics, and then we'll have time for questions and answers. Okay, so I want to make sure everyone is everyone able to see the screen right now?
I don't see it yet, Ben.
Okay, I hope everyone's able to see the screen now. The first item we will touch on in the book is item number 4. So we'll be talking about the columns and the properties at that time. And if you don't want to know that, or the columns will have a name. There'll be 2 columns. The first one will have a name, and then each column will have 2 names, the first name and the last name, and that will help us divide the columns. So if a situation should arise or something from the previously, we want to save everything into categories, so we'll have icons related to each event. So you won't see pictures for each specific date. For example, you'll have you might have 5 items on a day, but they're not. It's a range. They're not exact. So you have to go by the true date, which can be the problem. And if you can't put down a date, then you'll have to save the information. So one way we can approach this is we can have a discussion about what to do, and generally, I can show you here in the next slide. Generally, there'll be one date approximately for each job, but the problem is that sometimes it's vague enough information. So imagine something were to happen in June 15th, for example, but that's not the true date that it occurred. So it's sort of that date. It's almost that date. It's okay, but it's not the best option. So if there's a problem with the date itself, then we'll have to gather more information. And we have the year, we have the month, and then we have the day. So the date is one column. However, that can be good enough, but it's not good enough for this application. It won't be successful if we do it that way. So now we have the year in one column. then we have the month in the next column, and we have the date in the third column. So how does that benefit us? If there's not a clear date, then we can leave the day blank. So we can leave that null. And that allows us to get more exact information. So we don't have that date, but we have an approximation. Is that good enough? Well, so we're searching. So suppose we find the date that it occurred, or we have a range of dates, but it doesn't show up in the result. It doesn't show up in the result. Or now we have some more specific information that we need to save, and we're searching for it.
Looking for it can be easier.
It can be. Let me show an example here.
I don't know how.
Okay, or we can do a comparison. So the SQL statement, it looks and follows the year, then the month, or we can provide a date range. Also, in that second option, that won't be successful because we don't have the true date. So it's possible that maybe you can kind of have a gut feeling that people will probably do a search and then maybe change it and realize once I have more information. So the first option is compatible. The second option, it's okay. We can do better, and then there's also a fourth approach. Okay, so instead of doing year, month, date, we can have a start and end. So then we can save the range that way. It's interesting because now we can put down a specific date, or we can put down summer, then we can define what summer means. For example, so like maybe something happens at the end of June, or June 15th through the 30th, June 15th through the 30th, the second half of the month. Okay, so then you notice June 10th through August 25th. That's kind of a strange description for summer, but you know that people like to save, and the school year typically the kids are off school in the summer, so that's why we have it ending from June 10th through August 25th. So that makes sense for that date range. That makes sense. we can be flexible with that. Let's hold here, see if there's any questions. Okay. Okay, someone let me know to... Okay, so you can you see the screen better now?
Okay, this is a new interpreter here, and we're going ahead here. Okay, so when we use the date range, we can also add one more column, provide information. Suppose we have a range and we put down the start date for summer. We could make up the date, June until August. We can also put down, it's around, it's not exact. And we can put more information for us to use. So I have a few examples where I feel like, you know the date, of course, and you put down the date, but in the application it doesn't work. So if things are a little unclear, we'll have to change something, expand the property and separate things out. So there are good examples where that kind of thing has happened. Let me see here. All right, so, and then the second item here on the screen. So on the second item, number 23, it's my favorite topic for discussion. If something doesn't match, if you're trying to find something, we have situations happen over and over again where they're looking for something, they're looking for a response in a drop-down menu, and it's not there. So the reason why is because we have maybe three approaches. First, there's frustrated frustrated join. So the last part, we don't. The client ID is null, and then we're connecting everything, and it's all disjointed. It's not matching. So we want everything to be connected, and there's stuff that doesn't match in there. So that's the frustrated join approach. Another approach is where something says it doesn't exist. So there's nothing to find. There's nothing in the system. So it's obvious there's nothing in there. So then There's a third one. This is the last one. I think it happens most often. I see people starting to learn SQL, and something's not in. It's easy to understand because they're looking to find something to match in the search, and they don't have it there, and there's a problem with that approach. So what needs to be done is, in the process, things need to be gathered and listed out and compared with the items, and that's the slowest thing that happens, not in. So those three things, really it's nothing. It's not a big deal. In the database, let me show you here. So it's running there. So the first, second, and third, there's the frustrated join, there's the doesn't exist, and not in. They all have the same results. They're the exact same result. And let me show you what, there's a plan, show you what it looks like here. So you notice frustrated join in SQL server. It's slower, and there's something that says 63%. Again, that's pretty expensive. It cycles through trying to compare things, and it wastes time. It takes up time in the search. Okay, and I hope that some plan that does not exist. Well, there's an anti-semi join, and that you'll never see those words in SQL language. The word itself does show up in relational algebra. So if you have a DB machine and an ANTI machine connected, that's a better option because the machines already know if they find that they can't find something, they don't keep searching. They're faster at dealing with the issue anyway. Let me show you this here. So you notice with not in, there's a lot of things that happen. There's a lot of activity. It's a lot of work. You'll never see not in because it's not successful. So you have the options frustrated join and does not exist. What I remember is MySQL. In MySQL, a long time ago, frustrated join was the best thing. Let me show you this.
Excuse me, can you get a better interpretation for frustrated join?
Hold on just one second. Yeah, so he's saying frustrated join. He's spelling the words in English here, frustrated join. That's SQL. Yeah, it's called frustrated join in SQL. That's what it's called. Like I explained before, the reason why it's called frustrated because it's at the end it's looking for the clause. It's looking for clause. It's saying it's a where clause. It's filtering for the where clause. It doesn't have a match. Did you have another question? Does that answer your question?
Yeah, that answered my question. I thought maybe it was a misinterpretation. I've never heard it, but it looks like it's accurate when I'm Googling it.
Yeah, that's true. Yeah. Again, people have different names for things. It's frustrated join is just how the terminology I use. So going back to the point, if there's an active plan like in MySQL, let me show you this. Yeah, I noticed with the plan, it shows the second use. It says 34 rows, okay, and then compared with does not exist here. I notice, so you notice now, we have two, we have the use clauses where, and then we have use index. It seems good, seems okay. And you notice the label depend under query and subquery, which means each time there's a row on the top, it checks each line and checks down in the rows, or each one checks down in the rows. So with does not exist, it's not the subquery issue. And it's worse because you could get 34 rows of does not exist. So it can have like 944 rows, and that's why it's a bad way to go. So I can hold on right now for questions, if you have any. What was the third item here? Okay. So here's a fun one. When we want item like 36, it could be divided, or we could divide the information. But what does that mean, divide exactly? What does that mean? So in the relational algebra, we have active name division, and it's not in SQL. We can always divide something. So say we have two schedules. We can find something along the rows in that schedule or in that chart, and then look at a second one, and let me show you what I mean. So if you have HR searching for people who have applied for a job, and they have requirements, 4 skills that the person must have, you can have like a menu with a ton of people, and then some have the skills, some do have some skills that maybe they don't match the requirements. Others have partial skills, they don't have all 4, and then you can just filter those people out, and what's left are the applicants who have all of the skills necessary. So then, for example, maybe you want to look for the worst products with the defects, things that are spoiled. You're looking for that. So, for example, over here, so we have 16 different reasons. Scrap. It has something no good, basically, and you make something, and the things that you need to throw out or need to be scrapped. So then there are reasons that something might need to be scrapped, and so we have all those reasons listed here, 16 of them. And then I have another example of the data there, an example of how you produce, say, bicycles, and they look good, and you add. We have a new inventory, and then suppose the company making it, they send some that are no good, and then there are several products that are failing, and here's what happens. So we can change the list and have like 16 reasons why the product is no good, and we can change that. So we have a bunch that are scrapped. Maybe half of the inventory, and for different reasons. You want to know why. Maybe the size was wrong. Maybe something was bent or something like that. So we have a situation where we're having products with the problems that are recurring, and we have all of the different reasons for the scrapping, and maybe we need to stop producing that product altogether, for example. So how do we find the defective products? I'm going to show you this here. So there are different explanations of what to do, like remember what I explained first. So we have 16 different reasons why we would scrap some products, and then we would try to find so we want to find all the different times to try and let me show you an example here. so we want to join reasons with the product order. And then below, let's see, and then so if we're counting, we want to know how many reasons, you know, we have 16, we have them there. So we want to match that with all the reasons things were scrapped. But maybe we didn't count enough. So suppose we had products, and 16 times each one had only one reason. I mean, obviously they'll have all different reasons to scrap things. And that's so we need to have a second part here. So that's important. I don't want people to make a mistake and be, you know, tempted to change something like this. So that text won't be successful because it's not connected to the work order. Let me show you what would happen here. And there's just so many products in here on the list, and so I mean we have 16 different times that we scrapped, and with 16 reasons, that's no good. I have to be careful. So with two different counting methods, and we're just getting one product that we need. We have the reasons for scrapping and everything. Now we have another approach here. So this one's fun because we have a second negative, or a second assignment. Hold on. Negative, second negative, a double negative. And so we're looking for all the work orders that don't have a reason for scrapping, and that don't have, or something that doesn't have a work order. So yeah, the reasons don't match up with the work orders. Also, I want to point out we use exist at the top, and that's because we don't want the name of the product.
Okay, so you'll still see the same row, but if I were to delete one of the exists, so you can see that here. There you go. There you go. That's better. Okay, so if we don't use exist at the top, then each row will have it, and it will repeat it 16. No, sorry, I'm wrong. They'll repeat it 131. There'll be 131 work orders over and over and over again. So that's why we only need it at top. So those are there are two options. So maybe we can add an indentation, an instant, or we can use exists. So those are the options. Okay, so that would work in a row. Personally, for me, I may have a different opinion, but I tend not to use does not exist. I try to avoid that. I tend to mostly. The reason that I don't use that is because there's more information in the query. And what I mean by that is that if you were to write a query and then later come back and read it and be like, well, I really wanted to do this, but the approach is hidden in your answer is hidden in the rows. So I like to avoid that. But there are different approaches. Okay, yeah, I know distinct. There can be with distinct. That could be wrong maybe in this situation, but when I first wrote exists, that was 68% slower. Have fun. The data itself is always varied. It's always varied. So I always encourage you to do tests. You make assumptions and then see how it goes and then see if you're successful or not. And I can stop now to see if you have any questions. Do you have any questions? So then another thing I like to encourage is item 3.1. That's when we speak about keeping the group small. And what do I mean by that? So, for example here, we have 3 columns, and included in each column is a by. So there's a product number, and then a name, product name, and then that could be successful, but but in my experience, when you have the query and you're writing the query, and you look at the group by, you see there's many columns, and it could be up to 10, 11, 12. And when you include the group, when you include the group, you can make references, and that's usually always clear most of the time. The reference, it's the report. The product report will show you the references. So it shows you what you need to reduce and change. I'll show you on this next slide. So you see the example now, and so you have you separate everything. Everything's been accounted for, and then you have the key. You have the columns, and you join them to the other reference points, the reference information. So now you don't need to include all the queries and all the group bys. So that's my preferred approach. It's clear, and you know what the query means, you know what the action is doing. But for future, you want to make sure you know what the action is doing. If there's a reference total, you want to know what that is. So, if you have any questions, I can definitely answer them for you. Go ahead, it's open. It's open for discussion. That's all we have for today then.